scattered diagram. Now, scattered diagram, the name itself which is saying that it's a diagram. Let me take an Excel file. I'll just show you this. Now, just now we have seen that x values and y values, right? So I'll just type those values over here. So x values are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's take 10 variables now. So it looks good if the data is very high. Okay, so now let us go with the differences of 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, and it's 50. Now x values and y values are there here. Now let us go for scatter diagram. Scatter diagram means actually we have to draw a graph with x axis and y axis, and on the x axis we have to plot the values 0, 1, 2, 3, 4, 5 up to 10. On the y axis you can plot the values from 0 to 50 or 60 with a difference of 5, 5 or 2, 2, however you would like to take on. See, depending upon your graph paper, you can plot your values over there. See, I'll just directly show on the Excel sheet directly. See here. Now, see, this is what that means, or otherwise we can take now. See, I'm just plotting these values. When x is equal to 1, what is the value of y? See, 0, 2, 4, 6. That means in between we have 1, 2, 3, 4, right? When x is equal to 1, y value is equal to 5. So I have plotted the value over here. Now, when x is equal to 2, what is the value of y? It is 10. So I have plotted here the combination of these values 1, comma 5, 2, comma 10, 3, comma 15, 4, comma 20. Now 4, comma 20 means 4 at 20. So this is the combination. 4 comma 20 means this is the combination. Next 5 comma 25. See, 5 will be at between of this 4 and 6, and 5, and here 25. 20 and 30, in between 20 and 30 we have 25. So that is how we try to plot the values onto the graph. Simply we will draw x axis and y axis, and we will plot those values over here. Now, basing on this diagram, how do we come to a conclusion whether it is a positively related or negatively related? See here, these are the combinations what we have to come up with a conclusion by using scattered diagram. So now, if the points are continuously increasing, like the answer what we have got now, okay, if the values are continuously increasing on a almost a straight line, then it is said to be a strongly positively correlated. Okay, that means if the values are increasing, x values are increasing as well y values are also increasing. If the graph is going in a 45 degrees angle, then we say that it is a positive correlation. Okay, it is a positively correlated. See, all these values are on the straight line. Just now we'll go with this one here. See, if I draw a straight line, all the points are on the same one. That means no point has been deviated from this straight line. Then we say that perfectly positively correlated. Perfectly positively. That means it's a strong positive correlation. Now, if there is any deviation of the points from the straight line, if there is any deviation, though the values are increasing, x values are increasing as well, y values are also increasing, but if the points are deviated from this straight line, then we say that it is also a positive correlation, but it's a weak positive correlation,
Yes.
weakly correlated. Okay, now next one, let's take one more example. Now let's take the same data. I'll just copy this. I'll change these values. This is a problem very simple for us to find out whether there is a correlation between two variables or not. If you get a problem on scatter diagram, never ever leave it. Okay, see again, By selecting this data, I'm going for the charts. I'm going to select the scatter. Now see these values. See this one. Now, if x value is increasing, that means from 0 to 10, it is increasing. But in the y variable, see the values are decreasing from 50 to 0. 50 to 0. That means if the value of x is increasing, but y is decreasing. So this is the graph which I have already there on our PPT here. So if one variable is increasing, the other variable is decreasing. That means if the line of the graph on the scattered diagram is coming down with the same 45 degrees, then we say that x and y are negatively correlated. See, I have taken some 2 or 3 minutes by plotting these values onto the chart by using Excel. But in your examination on your notepad, on your note, what do? You just draw the x-axis and y-axis. We will try to paste those values. That means the combination of x and y coordinates. Okay. See, when x is equal to 1, we have to plot y is equal to 50. Where is x here? In between 0 to 2 and 50. So this is the combination. That is how you try to plot these values. Okay. So once after doing that, just a moment. Why do we get two lines here? See here, if the line is coming down and all the points are very near to the line, that means almost all the points are on the line itself. So then we say that x and y are negatively correlated. Even in your examination also you have to do the same thing, but we will not draw the same straight line, but we try to join all the points. You will try to join all the points. Let's take one more example. I just go with some values like 1, 2, 3, 4, 5. See, let's take this. See, now this is not on the straight line. These are some curved lines. Now let us go with the same thing by see this. That means here also we can say that x and y are positively correlated. X and y are positively correlated. But what is happening here? I cannot say that perfectly positively correlated. It's not exactly equal to 1 because there are some ups and downs in this line. So then what do we say here? That is called as weak positive correlation. That means if the values are being deviated from the straight line, then that is called as weak positive correlation. If all the values are on this line itself, then it is called as positive correlation. And now if the graph of the given distribution is coming down, then we say that it is a strong negative correlation. Okay, again, if the line of this graph, let us suppose while it is coming down, if there is any disturbances, that means if it is coming like a wave, then it again we say it as weak negative correlation. And the last one what we have is the concept what we have is, see this, the values of x are increasing, but let's take one. Yes, see this. See, I'll just draw the line also for this. See, x value is increasing here. X is equal to 1, it is 5. X is equal to 2, it is 5. X is equal to 3, y value is 5. X is equal to 4, y value is also 5. That means though there is change in x value, there is no change in y value. That means x value is not going to affect y value. So in such cases, in such cases, we say that X and Y are not correlated. Okay, that means if there is no effect of X on Y, then we say that there is no correlation. See this last diagram on the screen. See, if I take this one, can I draw a line either to the upward direction, downward, or in a horizontal line, wherever? Can I draw a line? No. So in such cases, we cannot decide whether the X values are increasing or decreasing. Sometimes it is increasing, sometimes it is decreasing. So in such cases, we simply say that there is no correlation between two variables. So now, see, whatever the problem is given to us, we'll just plot the values onto the graph so that finally we'll come to the conclusion. Just a minute. Okay. So let me take these two values of X and Y. Now, see, I cannot say that X is increasing, decreasing, Y is increasing, decreasing. See, the first case, X is increasing. See, from 39 to 65, X is increased. So from 47 to 53, Y is also increased over here. Okay, I think everyone can see this. Now, from 65 to 62, the value is decreased. Now, X value is decreasing. But see here, Y value is increasing from 53 to 58. So the first case, increasing and increasing, here it is positive correlation, but in the second case it is decreasing but increasing. That means X value is decreasing though Y value is increasing. That means basing on Y one value, I cannot decide whether the distribution is positively correlated or negatively correlated. Sometimes the values increases or decreases, these values also keep changes. Now for this data we have to find out whether X and Y are related, how they are related, whether it is a positive relation or negatively related. See, now let's draw some lines also here. See here, see this graph now. See, X is equal to some values now. Just a minute, I'll. Uh-uh. All lines were it is taking as two different variables. Okay, I'll just go with only scattered diagram. So that means basing on this, see this the values here, how they are going on. See, what are these points now? See the point which is near to 20. So that means this is the first value. When value of X is 25, the value of Y is 60. See, 25 will 20 to 40 means 30 will be here and 25 will be here. At the value of 25, the value of Y is 60. Similarly, we have plotted all these values. Now, by basing on these points, now can we see that there is an increment in the points? Of course, right? There is an increment. So that means by seeing these values, I can say that X and Y are positively correlated. See, by seeing these values, we cannot come to a conclusion that whether directly X and Y are perfectly positively correlated or whether negatively correlated. But only by joining this, that means plotting these values, we can come to a conclusion that whether they are positively related or negatively related. First you have to plot these values, then you can go for just simply joining these values. See, I have used these lines, but what is the combination what I'm getting over here is, see, first point starting from 47 to 53. So that is how it is going to join all these values. So once we draw it on a paper, see what we do here, we will just join these values from these things. See, it would be like a wave kind of thing. It goes up, come down, and to the upward direction. See, downward direction to the upward, downward, upward to the upside direction, down and to the upward direction. But finally, our graph is going towards the upward direction. So we say that X and Y are positively correlated. That means by using scatter diagram, I can just say that whether they are increasing or decreasing. That means whether there is a relation between two variables X and Y. Directly simply take these values. Even in your examination also, they'll be giving you an graph sheet to you. So simply plot the values of X and plot the values of Y over on the Y axis. Simply plot the values and try to join those points. It is not that you have to start with first point like 47. Whatever the first value you are having here, from there try to join these values onto the right hand side and just simply go up to the last value, so that finally you'll come to a conclusion whether the line is going upward direction or downward direction. If it is in the upward direction, simply write down that X and Y are positively correlated. If X and Y are X, and that means the line is coming down, simply write that it is a negatively correlated. Or the third case is, let us suppose you are not in a situation to identify whether it is increasing or decreasing, then you can simply write down that there is no correlation between X and Y.